All right, lesson 1.12B. So we're still talking about transformations of functions, and our skills and learning objectives are still to use transformations of functions to graph polynomial and rational functions, and then construct a function that has specific additive and or multiplicative transformations. All right, so it says we can also use the transformation rules for polynomial functions as a rapid method to write expressions for the transformation and or find values of a transformed function. So example 7 here, it says the table gives values for a polynomial function f at selected values of x. Let g of x equal a times f of bx plus c, where a, b, and c are positive constants. In the xy plane, the graph of g is constructed by applying 3 transformations to the graph of f in this order. All right, and so we're going to find a horizontal dilation by factor 3 with a vertical dilation of factor 2, vertical translation by 5 units, and then wants to know what is the value of g of negative 6. So let's just start with g of negative 6. Is what were our final goals. So g of negative 6 equals. Now I'm just going to plug that into this general equation at first, okay? Actually, let me write this above, not right there. All right, so g of negative 6 will equal a times f of b times negative 6 plus c. Now, what's that horizontal dilation of 3? So that means that that's our b value. But remember, b is inside with x, so we're not really going to multiply by 3. We're going to divide by 3, which is the same as multiplying by 1/3. So now we know that g of negative 6 is equal to a times f of 1/3 times negative 6 plus c. Or we can clean that up a little bit. And so we have a times f of negative 2 plus c. B then says we're going to do a vertical dilation by a factor of 2. So vertical dilation, that is our a value. And remember, vertical does what it's supposed to, so we know a is 2. So building on our previous equation there, we know g of negative 6 is equal to positive 2 times f of negative 2 plus c. And then we can keep going to c. It says a vertical translation by 5 units. Vertical means it's the y value. It's our outside of the x. And up or down, the translation is in this case, they called it c. So I know c is a positive 5, so it means we're going to go up 5. So now we know that g of negative 6 is equal to 2 times f of negative 2 plus 5. And then finally it says to find the value of g of negative 6. So for that, we're going to come over to our table. All we need now is f of negative 2. And we know that f of negative 2 is equal to 12. So I'm going to plug that in. So we know that g of negative 6 is equal to 2 times, we said f of negative 2 was 12 plus 5. So 24 plus 5, which is 29. All right, transformations of a piecewise function. So example 8 says the graph y equals f of x consisting of 6 line segments is shown for negative 4 less than or equal to x less than or equal to 4. A says sketch the graph of h of x using the following transformation, and then B says state the domain and range of h of x. All right, so when we look at this transformation, that x plus 2 tells us that we're going to go to the left 2, and the minus 3 there tells us we're going to go down 3. So I'm literally just going to take each of these points and I'm going to move them in that direction. So I'm going to take this point right here, and I'm going to, let's see, it's at negative 4, 1. So I'm just going to kind of mark it lightly on this graph. Negative 4, 1. And so I am going to go, what do we say, left 2 and down 3. And then I'm going to take this point right here. And I'm going to go, let's see, that's at what, negative 2, negative 1. It's hard because the scale's off a little bit, so right there. and I'm going to go left 2, down 3. I'm going to go ahead and connect those. And I'm going to go to the next point, which is at -1, -1. So I'm going to go left 2, down 3, and mark that. And connect. And then I could even go through 0, 0 since it goes through it, or I know it's a straight line all the way up to this point. So I'm going to go ahead and go to 1, 1. And I'm going to do the same thing, left 2, down 3. Oops, didn't change colors. And connect. Next point, up there at the top. So that's a what, 2, 3. I'm going to go left 2, down 3. And I'm just going to keep going. Next point, 3, 1. Go left 2, down 3. And then finally my last point. It's at 4, 0. And I'm going to go left 2, down 3. And connect it. So there's my transformed graph. Now we can see in our original one here that our domain was -4 less than or equal to x less than or equal to 4, like they had written it. It's the only reason I wrote it with inequality signs. And our range then went down to -1 less than or equal to y, and it went all the way up to 3. Now, since we have the graph on the second one, we can just look at our graph and pull our domain and range. And so for this one, our domain goes from -6 to +2. And our range goes down to -4, up to 0. Now, if they didn't tell me that, just as a reminder thing, remember that it says here that it says x plus 2, which we know x is the opposite, so we would subtract 2. So if you subtract 2 from these, you would get -6, and you would get 2, the same thing we got there. All right, and the range, that's going to be, this here says our y values are -3, so if you subtract 3 from both of these, we got -4 to 0, which is the same thing we got there. All right, applying transformations. Example 9 says the function f is not explicitly given. In the xy plane, the graph of h is created by a sequence of transformations on f. The graph of h is the result of a vertical dilation of the graph of f by a factor of 1/2, then dilating horizontally by a factor of 1/3, then translating horizontally to the left 7 units, and finally translating vertically 3 units down. What is the equation for h of x in terms of f of x? All right, so h of x equals. So remember, a comes first, and a is our vertical dilation, which it says a factor of 1/2, times f of, says it's then horizontally dilating horizontally by a factor of 1/3. Now remember though, the number is, we're not going to divide by 3, we're actually multiplying by 3, so we're going to put a 3 in here. Then it's going to go to the left 7, so that's going to be our x minus 7. And then translating vertically 3 units down, so subtract 3. All right, example 10. 10, you got to watch the wording because they do it in a different order here, okay? So it says in the xy plane, the graph of g is vertically translated translation of f 10 units down, and then a vertical dilation by a factor of 1/2. What is the equation for g of x in terms of f of x? So we're going to have g of x equals. The first thing it says is it's going to go down 10 units. So we know that's going to be our f of x minus 10. and then the vertical dilation. So then all of this is going to be times the vertical dilation of 1/2. All right, now I should have wrote that smaller because it actually gave me an equation. So then I'm going to plug it in and work on this. So let me rewrite this real quick so I have some room. Sorry about that. So what we just said was we had our f of x. We're going to go down 10 units, and then all of that at a vertical dilation by 1/2. All right, but since we know f of x on this one, unlike the other one, we can plug it in. So we get 1/2 times f of x is 2x squared plus 6x plus 8, and then we have our minus 10. So this is 1/2 times 2x squared plus 6x minus 2. And if you distribute that 1/2, you'll get x squared plus 3x minus 1. So there's our new equation. All right, example 11. The partially completed tables of values represent the functions g of x and h of x, such that h of x is equal to 4 times g of 2x minus 3. Find the missing values in the table. All right, well, let's see. Let's just start with, we're looking for g of 0. So I'm going to start with h of 0 to help me with that. So we know h of 0, looking at our h table over here, is equal to 9. But it also tells me that h of x is equal to 4 times g of 2x minus 3. Well, if I'm looking for x is 0, then I know that this means that 9 is equal to 4 times g of 2 times 0 minus 3. So 9 is equal to 4 times g of 0 minus 3. Move the 3 over. So 12 equals 4 times g of 0. Then divide by 4, and we get g of 0 equals 3. All right, now the thing is that you got to remember that the g that you're looking for is 2 times the x value, okay? So that's in the h equation. So if I'm looking for 2, then I'm going to use the x value of 1, because 1 times 2 will give me this 2 that I'm looking for, okay? So then I'm going to use h of 1, which is equal to 2. And so we know, using the same equation, then that 2 is equal to 4 times g of 2x, which is, our x is the 1 right there. So 2 times 1 minus 3. So 2 equals 4 g of 2 minus 3, and then solve for g of 2. So 5 is equal to 4 times g of 2, divide by the 4. And so we get g of 2 is equal to 5/4. Now, I'm looking for h of 3. So we're just going to plug in h of 3, because we don't know what h of 3 is, but we know h of 3 is equal to 4 times g of 2 times 3 minus 3. So h of 3 equals 4 times g of 6 minus 3. So h of 3 equals 4. We know g of 6 is negative 2 minus 3, and so we find that that is equal to negative 11. And then we're looking for h of 4. So we're going to do the same thing. It's 4 times g of 2 times 4 minus 3. Is 4 times g of 8 minus 3. G of 8 we know is negative 1. So it's 4 times negative 1 minus 3, which is negative 7. And we're able to complete our table. All right, and then transformations of rational functions. So example 12 says the graph of f of x is shown below. A says write the equation for the rational function f, state its domain and range. Well, when we see this, we can see that we have a horizontal asymptote at y equals 0, and we have a vertical asymptote at x equals -2. So when I go to write my equation, we know then that f of x will equal, well, the vertical asymptote is x equals -2, which means in the denominator we have the factor of x plus 2, and I don't have any x-intercepts, I don't have any holes, so we're just going to put a 1 on top. And then check it. Does that give us that horizontal asymptote at y equals 0? Yes, because our our highest degree is in the denominator. All right, B says use the grid to sketch a graph of G as a transformation of F. So we're going to take this equation. Oops, I forgot to do domain and range. I just happened to notice that up there. Let's do domain and range. So the domain here, notice that my x's keep going to the left, and they go all the way until that vertical asymptote. So all the way to -2. They're going to jump over that vertical asymptote, so then -2 all the way to positive infinity. Our range keeps going down, so it's -infinity, and it's going to go up, and this time it does not cross that horizontal asymptote, so it's going to go to 0. It's going to jump over it and 0 to infinity because it keeps going up. I'm sorry, now for B. It says use the grid to sketch a graph of G as a transformation of F, given that G of X is equal to -2 f of x minus 4 plus 3. Oh man, I should have scooted that up a little bit. Let me do that. All right. So I'm going to go and I'm going to pull a few points off of this graph. So for one thing, we had drawn in, we said we had a vertical asymptote at x equals 0. I'm sorry, x equals -2. And we had said we had a horizontal asymptote at y equals 0. I'm going to need those. And then I'm going to pick a couple points. So this point here looks pretty good. So what's that? -3, -1. And then I could use that point right there, which is -1, +1, to help me graph my function. So when I go to do my transformation one here, looking at the equation, notice that this says my x is going to go to the right 4. So that means we're going to take our x's and we're going to add 4. So I'm going to take both of these x values and I'm going to add 4 to them. So -3 plus 4, -1 plus 4. And then I also have this x value, so I'm going to add 4 to it too. So my vertical asymptote is now at x equals +2. Now for my y values, I can see here that it says -2 times f of x plus 3. So we're going to take our y's times -2 and we're going to add 3. So y times -2 and add 3. So now I'm going to take these x values times -2 plus 3 times -2 plus 3. So there's my two new y values I'm going to use. And then I'm going to take this y value times -2 plus 3. And so now my horizontal asymptote is going to be up at 3. So my horizontal is up here at 3. My vertical is at +2. I've got a point at 1,5. Well, I'm going to click something. And I've got a point at 3,1. So this tells me I'm going to graph in this little area here and that little area. And so there's our graph. C says describe the transformations that change f of x to g of x. Well, we're just going to go through the pieces. So we can see that the negative, remember, was a reflection across the x-axis. And so does it look like my graph flipped upside down? It does. The 2 is a vertical dilation. I notice I like the word dilation, so we're going to change it by a factor of 2. The 4 is inside with x, so I know it's horizontal. It's being added or subtracted, so it's a translation. It's a minus, so we're going to go to the right 4. And then at the end there, that plus 3, it's not inside with x, so it's vertical. It's being added or subtracted, so it's a translation. And it's a plus 3, so we're going to go up 3. So check your graph. Did it do what you thought it would? Like we started out, did it turn upside down? Reflect across the x-axis? It did. Does it look like it's stretched out? That one's a little harder to tell, but I think so. Horizontal, did it go to the right 4? It did. Did it go up 3? It did. So I think we're good. And then D, you can barely see it there on mine. It's the domain and range of g of x. Well, only issue you have with your domain is that your vertical asymptote there. So your domain is going to go from negative infinity to your vertical asymptote at 2, and then it's going to jump over it, so 2 to infinity. Your range, the only issue is that horizontal asymptote, so negative infinity to 3, jump over it, 3 to infinity. Remember, the other thing you have to watch out for would be your holes, okay? But we didn't have any holes in this graph. And then finally, example 13, just a review. So state the vertical and horizontal asymptotes for each function by using the standard form equation of a rational function y equals a over x minus h plus k. All right, so A is really just a review one. So our vertical asymptote, well, nothing cancels, so I know that it's going to be the denominator equal to 0. So it's at x equals 3. And my horizontal asymptote, where's my highest degree? It is on bottom, so therefore it is at y equals 0. Now, remember with the transformations, this is your a value, this is your h value, and this is your k. So if you remember on your parent function, if you just do 1 over x, okay, your vertical asymptote is going to be at x equals 0, and your horizontal asymptote is at y equals 0. So if you look at this graph, if you multiply by a number, 0 times any number is still 0. So you just have to really worry about your h and k. So what it's going to come out to be is that your vertical asymptote is going to be at y equals, as long as it's, well, I hate to say it's your h, it's going to be the negative h, okay? But you got to be careful. That's as long as it's just x plus or minus and a number. If there's any number in front of the x, then we have to divide. So I guess really we could say it's negative h divided by b. How about that one? I think that works better. And that's your horizontal, not your vertical that I just wrote it on. So it's going to be y equals negative h over b. And then your vertical, dang it, that's where I got mixed up. I am not starting this video over for this. I apologize. H is with x. This is going to become x equals your negative h. Again, so I was right. I was right to begin with. I just wrote y equals instead of x equals. I apologize. Then your horizontal asymptote is just going to be your y equals your k value. All right? So, and you can see that on this one. If I take my h and I do negative h divided by my b is 1, so negative 3 divided by 1 is 3. My k, I'm not adding anything there, so it's a 0, and so my k value is my horizontal. Same thing here on b. So I know it's going to be x equals negative 4, and then my horizontal is y equals the negative 5. Now on C, you got to be a little careful because now it's not just x, it's a negative x. Our b value there is -1, okay? So when we do x equals negative h over b, we're going to get -5 over -1, which tells us that x equals 5. And then y equals, from our horizontals, just that k value of 3. And then the same thing, if you notice, be careful here. So we've got x is equal to, my h is going to be 12, so -12 divided by b, which is -1, so we get x equals 12. And then here is my k, they moved it to the front this time, which is a +4. All right, and that is the end of lesson 12.